Hello there, class, and welcome back. I'm on page 36 of the TABE Tutor Practice Math book. This is practice 39 about the metric system. If you haven't watched the lesson video for this one, you really need to do that first because we go over the prefixes and their meanings in that video, and it will let you understand much better what we're doing here. So these are some application problems with the metric system. They've given us the basic conversions up here for length, mass, and capacity. Remember, length measures distance, mass measures weight, and capacity measures volume. How much liquid, or not necessarily liquid, but how much space you can fill. You may use a calculator on this one. And let's take a look at number 1. An elephant has a mass of 2.5 metric tons. Elephant, 2.5 metric tons. A hippopotamus has a mass of 1,600 kilograms. How much more, that means subtract, mass does an elephant have? So what they're wanting me to do is subtract the elephant minus the hippo in terms of mass. And let me actually bring that right over here. I'm going to try to squeeze these in, but I may not be able to. We'll just have to see. So this is 2.5 metric tons. And then 1,600 kilograms. So I either have to convert the elephant or the hippo, and since all of my answer choices are in kilograms, I'm going to convert the elephant. I want to get that down to kilograms. So when I look up here, I see that 1 metric ton is 1,000 kilograms. So I'm going to say 2.5 metric tons times 1,000. And you can use your calculator. It's allowed on this lesson. So 2,500 is the elephant's weight in kilograms, minus 1,600 kilograms for the hippo. So when you subtract these, you will get a difference of 900. So we're doing exactly the same type of thinking that we did in the last lesson. We're just dealing with the metric units this time, which I much prefer. I would be very happy if the United States went to the metric system, but I am in the minority, I believe. So number 1, the answer is B. Number 2, Meg has 8 teacups. Each teacup holds 250 milliliters. How many liters of tea does Meg need to fill all 8 cups? Well, if you watched the last video with me, the last practice, you saw me do a lot of these drawings, so I'm going to continue that. Teacup holds 250 milliliters, and she has 8 of those. So I'm going to say 250, rather than draw them all, I'm just going to say 250 times 8, using my calculator. That's 2,000 milliliters. So she would need 2,000 milliliters of tea, but that wasn't the question. The question is how many liters of tea. So I'm going to use a proportion on this one. This is still one of my favorite ways of doing these problems, but some people don't like it, so I try to mix it up a little bit. I'm going to convert milliliters and liters. And so when we look up here to our conversion, this is capacity. A liter is 1,000 milliliters. So 1,000 milliliters is 1 liter. And she needs 2,000 milliliters of tea. So 2,000 times 1 is 2,000. And 2,000 divided by 1,000 is 2. This is why I like the metric system, because the units or the answers, the numbers, are usually easy to do in my head, as opposed to standard units where they don't end in zeros most of the time. But anyway, answer 2 is C. Tom's shelf is 3 meters long. So this is a distance problem. A planter, and they mean a planter like a flower pot, is 75 centimeters long. How many planters can Tom put on his shelf? Well, you know what I'm going to do. There's the shelf. Whoa, that's pitiful. Guys, I can't draw a straight line to save my neck. So here's the shelf, and it is 3 meters long. And then he's going to put planters, and I'm assuming there's no space between the planters. We're just going to slide them in there like so. So this is a planter. This is 75 centimeters. And this is another 75 centimeters. So what am I doing? I'm breaking down. I'm taking the shelf and I'm breaking it down into the number of planters. But I have a problem. I have meters and centimeters, and I can't do that. They have to be the same unit. So I'm going to convert the meters. I know that there are 100 centimeters in every meter. So 3 times 100, that's 300 centimeters. It's the same distance, just written as centimeters. Then I'm going to break down 300 by 75 and see how many times that will fit. 300 divided by 75 is 4. So my picture is definitely not to scale. It should look more like this. And since I took the time to draw the picture, let's make it as accurate as we can. I'm going to cut it in half and then cut those in half. This is still not very accurate, but it's better. We have 4 of those planters lined up on this shelf. So 75, 75, 75, and 75. 4 planters. If you remember that you can't mix units, you'll be okay. You have to convert those meters. You cannot mix the units. Okay, the next one. Number 3 was A. Number 4. Nick walks his dog 2.8 kilometers every day. After walking for 975 meters, he stops to talk to a neighbor. How much farther, that's a subtraction word, does Nick have to walk? So given what they've told me, you guys know that if somebody's moving or something is moving, I always draw it. So I'm going to draw the total distance. So Nick walks his dog this whole distance, which is 2.8 kilometers. And they tell me that he stops to talk at 975 kilometers. Not kilometers, meters. Excuse me. So where, first of all, is he on this line? Is that a lot? Is it not? Is it halfway? Is it more than halfway? I don't know that until I figure out how many meters are in those kilometers. So I'm going to convert kilometers into meters. Now I know that there are 1,000 meters in a kilometer. So I'm going to say 2.8 times 1,000, that's 2,800 meters. So this whole line is 2,800 meters. The 975 would be about right there. So this is where he stops to talk. This is the 975 meters. What we're looking for is this distance. How far do they still have to go? This is where he meets the neighbor. And that lets you see the subtraction. So 2,800 minus 975. I have a calculator. I'm going to use it, especially today. I'm just not doing well with my mental anything today. So 1825. The answer to number 4 is A. Number 5. Jen prepares a bath for her child with 110 liters of water. By the end of the bath, she cleans 9,500 milliliters of water off the floor. How much water remains in the bathtub? Remains is a subtraction word. So here's the bathtub. And I'm going to assume that it's filled to the top. That is 110 liters. And it's filled to the top. At the end of the bath, there are 9,500 milliliters of water on the floor. So the baby has splashed out a lot of the water. But I really can't tell you how much until I make this conversion. Where is 95 milliliters in relation to that 110 liters? So let's go ahead and make the conversion. I'm going to do it right here. 110 liters. And let's look up here if you need to. There are 1,000 milliliters in a liter. So we're going to multiply that by 1,000. And again, I like these because I can just, 1 times 11 is 11, and it has 4 zeros. But you can use the calculator if you need it. So this bath holds 110,000 milliliters. So we are talking about just a tiny sliver that got splashed out. We're talking about just this little bit that splashed out. This is the 9,500 milliliters. So what we're looking at is what's left in the bathtub, how much remains in the bathtub. So I'm going to say 110,000 minus 9,500. Now, if you, oh my, I messed up, but let's go ahead. We'll finish it right here. I should have converted everything to liters to start with. If you want to put your commas in there, that's fine. I don't use commas, but I know that on these big numbers, that's probably a good thing to do. Okay, so we end up with 100,500 milliliters. Here's what I did wrong, but it's okay. This happens. If you look at the answer choices, They're in terms of liters. So I should have made the conversion to liters to start with. But I can do it right here. It's not a big deal. To convert that to liters, you're going to divide it by 1,000. Because we're going back to that larger unit. So let's do 100,500 divided by 1,000 is 100.5. So C is the answer we're looking for, 100.5 liters. I went to all milliliters. I should have gone to all liters to begin with, but it works the same way. If you make that mistake, don't stop, just keep going and then convert back and it'll be fine. Alrighty, number 6. Jerry catches a 35 centimeter long trout while fishing. Bert catches a 27 centimeter long trout. Which statement is true? Well, when I look at those answer choices, there's a word that keeps showing up: total. And that's telling me to add. So I'm going to take Jerry's fish, which is 35 centimeters. And then I'm going to take Bert's fish, which is almost as long. Again, don't look at my drawings. Just don't go with what they look like. Go with what they say. So add those together. 35 and 27 is 62 centimeters. Okay. The total length of both fish is 0.38 meters. Be careful. My answer is in centimeters. So is 62 centimeters and 0.38 meters the same thing? That's the question that we would have to know. And it is not. Okay. A meter is 100 centimeters. So the two fish together do not come up to a meter. They're still less than a meter. The total length of the fish is 0.38 meters. That is not true. The total length would be 0.62 meters. B says the total length of both fish is 1 meter. That is not true. The total length is less than 1 meter. It's only 62 hundredths of a meter. The total length of both fish is 62 centimeters less than 1 meter. Okay, remember this keyword. Less than means to reverse. So you're saying 1 meter, which is 100 centimeters, minus 62 is 38. And this is the total weight or the total length of the fish? No, that is not true. The total length of both fish is 38 centimeters less than 1 meter. Well, let's see if that proves true. 1 meter, which is 100 centimeters, minus 38 is 62 centimeters. That's true. So D is the answer. They're trying to mess with our minds on that one. Have to really, really read carefully to make sure that you have the answer you need. Number 7. Nolan has an 8-kilogram bag of potting soil. He sets aside, that's taking away, 2.5 kilograms of soil and evenly divides the rest, there's subtraction, among 11 pots. How much soil does Nolan use in each pot? So I'm going to draw a big bag of potting soil. And I'm going to tell you that it weighs 8 kilograms. That's all he has. And then he sets aside 2.5 kilograms. So he takes out about maybe this much. I'm just guesstimating. He sets aside 2.5 kilograms. So we need to find out how much is left over here. So we can do that. We can say 8 in the whole bag minus 2.5 is 5.5 left over. So this is the 5.5 kilograms that he's going to put into pots. And he's doing that. Let me just write it out this way. I don't need to. He's taking that 5.5 kilograms and he's dividing it 11 ways. And so let's do that. Let's say 5.5 divided by 11 equals 0.5 kilograms per pot. So that's great. Or is it? When I go to get my answer, it isn't there because those units are grams. So we need to convert kilograms that we found into grams that we are given as answer choices. And I'm going to do that with a proportion. There are other ways if you don't like the proportion. But I've got kilograms. The answers are in grams. And this is going to tell me what I need to know. Go up to your chart and find the kilogram-gram conversion. And it is right here. 1 kilogram, 1,000 grams. Bring that information back down here. 1 kilogram, 1,000 grams. And we're converting that 0.5 kilograms. So here comes the math. It'll work every time, guys, without fail. If you set it up right and you do it right, you've got it. So 1,000 times a half, think of it that way, is 500. And 500 divided by 1 is 500. Something has gone horribly wrong with my iPad. Bear with me just a minute. I think I hit things and okay, here we go. Sorry. 500 is what you're looking for. So that is C. Number 7 is C. All right, number 8. Alice sews a quilt that is 2.4 meters wide. Each patch is 12 centimeters wide. How many patches fit in one row across the quilt? So I'm going to draw myself a sketch of the quilt. I hope her quilt doesn't look like that. And we want to know about 1 row across. So we're not worried about this bottom half. We're just focusing on, in fact, I'm going to take that out. I'm just focusing on 1 row of the quilt. And it tells us that it's 2.4 meters wide. So they tell me this part. And they tell me that each of the patches on the quilt is 12 centimeters wide. So let me let you get the idea of what I'm doing. I am dividing, right? I'm taking that 2.4 meters and I'm dividing it up in 12 centimeters. Now there's a problem. I can't do meters and centimeters. I have to do meters to meters or centimeters to centimeters. And I'm going to convert this one. 2.4 meters, there are 100 centimeters per meter. So this width is actually 2,400 centimeters. Now I'm good to go because I have centimeters and centimeters. I can do that division. I can say 2,400 divided by 12 is 20. So there are 20 patches across that top row, or any given row. So for part A, on number 8, let's go with D. Alice makes another quilt that is 2 meters wide. She designs the width of the quilt with 8 patches and a border. Each patch is 24 centimeters wide. So what is the total width of the border? Now this one's a little bit more of a challenge. At least the thinking is more of a challenge. So let me draw a picture to get us started. So here's another row. I do it every time. I forget to hit my shape tool and it comes out all wonky. Okay, so we know that this quilt is 2 meters wide. I'm going to go ahead and convert that to 2 times 100, that's 200 centimeters. So either way we talk about it, it's the same width. Now this time, she's going to have a border, which means it will be over here as well. And then she's going to put in 8 patches. Okay. So we have to figure out this dimension. We know that there are 8 patches and that each of them is 24. So let's figure out how much space that's going to take up. 8 times 24 is 192 centimeters. So if you take 200 minus 192, that's going to be a difference of 8. So I'm going to put 4 of those centimeters on this side for the border and 4 for this side of the border. So 4 centimeters and 4 centimeters. That's a total of 8 centimeters worth of border. But when I go to pick my answer, it isn't there. The answers are in terms of millimeters. So I'm going to do my proportion. And I'm converting centimeters. And let me just draw for you. I'm taking this 4 centimeters and this 4 centimeters. That's a total of 8 centimeters. And I want to convert that into millimeters. So we need to know the relationship between centimeters and millimeters. I'll look up here. A centimeter is 10 millimeters. A centimeter is 10 millimeters. And you and I have to work with the border, which is 8 centimeters. 8 times 10 is 80. And 80 divided by 1 is still 80. And that's millimeters. So A is the answer. I make quilts, and I can tell you that I actually do this kind of math all the time. This is very common. If you are a quilter, you will recognize this kind of math. All right, number 9. A rescue center receives a little brown bat which has a mass of 2,650 milligrams. That's like 2,000 aspirin. The bat gains milligrams at the center. The bat must be at least 8 grams before it can be released. Which 2 statements are true? So here is a picture. Okay, we want this bat to weigh 8 grams before we can let it go. So it's got to weigh 8 grams. Now, when it comes in, it weighs 2,650 milligrams. That's when it first arrives at the center. And then it gains some weight. It adds on 4,475 milligrams. And we want to know if it's ready for release. Is it ready to be released? So I'm going to add. We're going to start with his base weight. When he came to the center, this is how much he weighed. And then he gained some weight. So let's add that on. And that means that right now the little bat weighs 7,125 milligrams. So the question is he big enough to release? Well, before I can tell you that, I have to convert those grams to milligrams. I'm not going to, well, let me do it. I tell you don't be lazy, but let me do it. 1 gram equals 1,000 milligrams. Look back before you make this math. So 8 times 1,000. He needs to weigh 8,000 milligrams before he can be released. So he doesn't. He's not ready for release. And let's figure out how much he needs to gain. So I'm going to say 8,000 minus 7,125 is just, he's close. That's 875 milligrams that he needs to gain. So this number, he needs that 875 milligrams before he can be released. So which 2 statements are true? The bat is ready for release. No, the bat is not ready for release. So that is true. The bat has a mass of 7.3 grams. No, he has a mass. This would actually be 7.125 grams. The bat has a mass of 8.1 grams. No. The bat needs to gain 875 milligrams before release. That is true. The bat needs to gain 5,000 some milligrams before release. No. He's close, but he still has just a little bit to go. So the answers to number 9 are B and E. Number 10. Amanda needs 85 hundredths of a liter of pineapple juice for a recipe. That's what she needs. The capacity of a bottle at the store is 170 milliliters. So how many bottles of pineapple juice does Amanda need to buy? Well, let me sketch for you. And I did it again. I thought I would catch it. Here's what Amanda needs. This problem is about me. So I need 85 hundredths of a liter of juice. And the bottles at the store have 170 milliliters. So how many of these do I need to fill my container? So I'm going to convert liters to milliliters. 1 liter is 1,000 milliliters. So I think I'm going to use a proportion just to keep this one organized. This one could get away from you in a hurry, so keep it orderly. We're converting liters into milliliters. My recipe is in liters, the bottles are in milliliters, so I'll have to find the connection. 1 liter is 1,000 milliliters. I need this many liters. So I'm going to say 1,000 times that number. Use the calculator. Don't risk trying to do this in your head. That's 850. Divided by 1 is still 850. And that's milliliters. And then I'm going to divide this 850 milliliters by 170. And that gives me 5. They could very easily give you a price per bottle and ask you to find total cost. But I need to buy 5 bottles of juice. Again, guys, you don't have to draw these pictures and all that stuff. I'm just doing that to help you see the picture and the connection. Number 11. Julian's truck has a mass of 2.3 metric tons. He transports 2,600 kilograms of equipment. Can Julian safely transport the equipment over a bridge with a 5-ton limit? And I'm assuming here that they mean metric ton, a 5-ton metric ton limit. Let me look before I get into this. Okay, yes. Let's take this, I'm going to take a look at Julian's truck. So here's the truck. And the truck has a weight, a mass of 2.3 metric tons. And then Julian has equipment. So this is the equipment. That is 2,600 kilograms. Now hopefully here you see the problem. You've got metric tons, you've got kilograms. Those need to be the same unit before you can work with them. And since the bridge is measured in metric tons, or the limit of the bridge is metric tons, I'm going to convert the equipment. That way everything goes to metric tons. So I'm going to do this one. And I'm converting metric tons to kilograms. And 1 metric ton is 1,000 kilograms. The equipment that Julian is trying to carry is 2,600 kilograms. So let's do the math. 2,600 divided by 1,000 is 2.6 metric tons. So I have 2.3 metric tons for the truck and 2.6 metric tons for the equipment. That is a total of 4.9 metric tons. And he wants to cross a bridge with a 5 metric ton limit. He's okay. The weight of his truck and his equipment is less than the bridge's limit. So yes, he can cross the bridge. No is not correct, so I can eliminate A. Yes, the mass of the truck with the equipment is equal to the bridge's limit. No, that is not true. Yes, the mass of the truck with the equipment is less than the bridge's limit. That is true. And D, yes, the mass of the truck with the equipment is greater than the limit. That is not true. If it were true, he couldn't cross. So the answer to this one is, number 11 is C. He can cross the bridge because his total load is less than 5. Number 12. A mirror should hang 7.5 centimeters from a light fixture. Deb measures 59 millimeters between her mirror and the light fixture. Number 12. A mirror should hang 7.5 centimeters from a light fixture. Deb measures 59 millimeters between her mirror and the light fixture. How should Deb adjust the mirror? Okay, so you know I'm going to draw this one. So here's the wall. You know I'm going to draw it wrong, don't you? There's the wall. And I'm going to put 2 points on the wall. So here's the mirror. And here's the light fixture. So Deb takes a tape measure and she measures between those two, and she gets 59 millimeters. Now the standard says that there should be 7.5 centimeters. So until we get these two things on the same terms or in the same terms, we're not going to know if she's okay or not. We're going to have to make the conversion to know that. So I am going to use a proportion. This is my go-to method for solving these. And I'm going to convert millimeters and centimeters. Those are the 2 units that I'm working with. So let's go to our little cheat sheet and look for millimeters and centimeters, and it says 1 centimeter is 10 millimeters. 1 centimeter is 10 millimeters. Now, she knows the millimeters. I want to convert that 7.5 centimeters. Let's convert the standard and see what it should be. And that's in centimeters. So I have 10 times 7.5. That is 75. And 75 divided by 1 is 75. So it should be 75 millimeters. But it isn't. It's only 59 millimeters. So what does she need to do? If it should be 75 millimeters, but it isn't, does she need to move them wider or closer? It needs to be wider. She's going to have to go this way with them. They need to be farther apart. And that's very important to fix in your mind. They need to be extended, moved away. So A and B are not right. A and B are saying that we need to bring them closer together. And I don't. I don't want to get them closer. I want to bring them farther apart. So the question is how much farther apart? And to find that, you would just say 75 minus 59, and that is 16. So she needs to move them 16 millimeters farther apart. And actually, I read the problem wrong. She's moving the mirror. So the light fixture's not moving. The mirror should move 16 millimeters away. Good question. Number 13. Jason's fence is 1.3 kilometers long. Dan's fence is 350 meters shorter. That's subtraction. And we're trying to find out how long Dan's fence is. So here's Jason's fence. And here's Dan's fence. Jason's is 1.3 kilometers. Dan's is 350 meters shorter, so that's this distance. And we want to know how long Dan's fence would be. So the first thing I'm going to have to do is convert either to all kilometers or all meters. And since Dan's fence is, let me think a minute how I want to do this and why. More importantly is why. Yeah, I want to convert Jason's fence because I'm working on Dan's fence. That's the number I'm trying to find. So let's do the conversion right here. 1.3 times 1,000 meters is 1,300 meters. And then if I do 1,300 minus 350, 1,300 minus 350, something just doesn't look right to me about this, but it has to be. That's 950. Oh, I know what it is. That's meters, and I have to convert it back to kilometers. So I will say 950 divided by 1,000 is 0.95. I'm going to show you another way to do this one. This one bothered me from the beginning because my brain was saying don't do it the way I just did it. My brain was saying do it another way. And let me show you the other way. And then you can decide which you like. Again, there's Jason's fence. Here's Dan's fence. This part, nothing's changed. This is the information from the problem. So Jason's fence is 1.3 kilometers, which we know to be 1,300 meters. We've already found that. And we know that Dan's fence is 350 meters shorter. So here's what my brain was wanting me to do. My brain was wanting to convert this part. So what I would do to convert that part, and I'm still going to use the proportion. I'm still converting kilometers and meters. I know that 1 kilometer is 1,000 meters. I want to take off 350 meters. This is what my natural inclination was to do. So 350 divided by 1,000. Be careful there. Put it in your calculator. Is 0.35. And then I was saying that 1.3 minus 0.35, and you know what's coming, is this number, 0.95. I was wanting to convert it all to kilometers. But either way works, guys. You can do it either way you want to. You just have to convert a couple of times. That's the thing. Either way you do it, you still have to do a couple of conversions. Okay, number 14. Linda has a necklace with a mass of 4,700 milligrams, and she has a ring with a mass of 7 grams. What is the total mass of Linda's jewelry? So we're going to add the necklace plus the ring. The necklace is 4,700 milligrams. The ring is 7 grams. And clearly, we have a problem. We have milligrams and grams in the same problem. So we have to convert everything one way or the other. I am going to go ahead and convert. Which one do I want to convert? Since most of my answer choices are in grams, I think I'm going to go that way. It doesn't matter. It's like the one above. You can go either way. I think I'm going to try this one though. So 4,700, I'm going to draw you the proportion so you can see where I'm getting all this stuff. We are converting our milligrams that we have into grams to match the ring. I know that 1,000 milligrams equal 1 gram, and 4,700 is the weight of the necklace. So I'll do 4,700 times 1, divided by 1,000 is 4.7 grams. And then I will add the 4.7 grams to the 7 grams, and I've got my answer. Number 14 is A, 11.7 grams. Number 15. How many meters are in 5,800 millimeters? Well, this is a nice one. This is just a conversion. You don't have to. Almost feels like a trick. We're doing meters and millimeters. And 1 meter is 1,000 millimeters. And we have 5,800 millimeters to convert. So 5,800 times 1 divided by 1,000 is 5.8. I wish they were all like that one. Answer is C. Number 16. Everett has 2 nickels that each have a mass of 5 grams and 3 pennies that each have a mass of 2,500 milligrams. Which coins have a greater mass? Oh boy. So we have 2 nickels. I'm not even going to try it. Let's just copy it because they need to be identical this time. There are the 2 nickels. And those each have a mass of 5 grams. So that's a total of 10 grams on the nickels. And then we have 3 pennies. Remember, I know the pennies are supposed to be a lot smaller. Just don't focus on that. We just want to focus on the numbers. And that's going to be true on a test, guys. They won't be to scale. So don't get hung up on, oh, the penny's supposed to be smaller. It is, but that's not the point of the problem. Okay, these are 2,500. And we've got 3 of them. So what's the total mass on those? 7,500 milligrams. Now, I'm going to have to convert one of them. I may have to convert them both. I'm going to go ahead and do my 10 grams because that one is going to be a pretty quick conversion. There are 1,000 milligrams per gram. So 10 times 1,000, that's 1 and 4 zeros. 10,000 milligrams. So can we agree that the nickels weigh more? The nickels are heavier than the pennies. So let's start there. A says the pennies are heavier, and that's not true. We know that isn't true, so let's get rid of that one. B says the nickels are heavier. That could be. C says the nickels are heavier. That could be. D says the pennies are heavier, and that is not true. So I can eliminate A and D just off the top because the pennies are not heavier. So B says the nickels are heavier. C says the nickels are heavier. But we got to figure out which of those is the true one. Now, let's go ahead then and convert. I thought this would happen. I'm going to have to convert both of them. So I'm going to say, okay, this 7,500 milligrams. If you do 7,500 divided by 1,000, you will get 7.5 grams. So those are equal amounts. It's just that one is grams and one is milligrams. If you look at the difference, 10 minus 7.5 is 2.5. This one is true. If you subtracted the 10,000 minus the 7,500, this would not be true. It would be 2,500 heavier. So B is the answer because the nickels are 2.5 grams heavier than the pennies. Okay, last but not least, Cindy needs 17 millimeters of weather stripping at the top of her door and 85 millimeters at the bottom of her door. What is the total length of weather stripping Cindy needs? So here's the door. And then we're going to add the weather stripping at the top and at the bottom. And here's the door. At the top, she needs 17 millimeters. And at the bottom, it was 85 millimeters. Total means add. So we're going to add the top stripping to the bottom stripping. That's 75 plus 85. I'm sorry, 17 plus 85 is 102 millimeters total. But when I go over here to pick my answer, the choices are centimeters. So I'm going to have to make the conversion, but we can do that. We're going to convert our millimeters that we found into the centimeters that we need. And I know that it takes 10 millimeters to make a centimeter, and we have 102 millimeters. So we've got 1 times 102, and 102 divided by 10. Be careful there. 10.2, that's centimeters. And that is going to be option A for our last problem. Okay, we have completed the lesson on the metric units. Gave you lots of practice with word problems, with conversions, whether you're doing the standard units or the metric units, the process is pretty much the same. You just have to know those equivalent conversions. In the next video, we get into some graphs that are called line plots. So that'll be a little bit different. But I will see you soon, and I hope you have a really good day. Bye-bye.